So this morning we're in session 2 of what we discussed last week. We're discussing creation, specifically this broader field of apologetics, right? How do you give a defense for what it is that you believe? And the specific field that I like to deal with is creation and science and how it ties in all to the Bible. And for the benefit of those who weren't here last week, this is going to be slightly unusual for a family Bible hour, in the sense that usually in the family Bible hour, we read a lot of passages in the Bible and we discuss it. I am going to deal with this completely differently, in that there will be very little Bible reading and there will be a lot of discussion about science. And the reason I do that is because of my own experiences with spreading the gospel among people who love science. If you tell them that the Bible says this or says that, they're not going to believe you. What you have to do is talk to them in a way that they understand, in the language of science, and perhaps some minds can be changed. Secondly, my aim is also for our young people who are going to go out into the world, and the first thing they're going to hear is, if you understand science, you can know for sure there is no God. And my desire in my heart is to show you that nothing could be further from the truth. And this is why the approach I'm going to take is that there's going to be very little Bible reading, and there's going to be a lot of talk about science. And what we'll do is we'll try to marry the two and see if the two agree. If you want to hear more about that, there's a recording last week. I did a defense of why we do things this way. So today is session 2 of 4. And if you remember, the first week talked about astronomy and earth sciences. We talked about this last week. We talked about what are the heavens and the earth. Today, we're in physics. We're going to talk about physics today. You know, what is time and space? And I've actually talked about this, parts of this, to this group before. So if you have heard me talk about this before, excuse me, some of this material is repeated, but to keep the whole series consistent, it's important that we talk about it. So we're going to talk about physics, what is time and space. The next session we'll talk about biology. How do engineers look at living systems, and does the existence of a soul and a spirit, does it actually even make any sense? The fourth session, I haven't really decided on what to do. I left a placeholder there called wrap up. If anyone has specific questions, any topics you'd like me to talk about, email me, text me, I'll try to talk about them. It's not that I don't have ideas on what to talk about, I just don't know what is useful to you. So if you have questions, let me know. That's going to be session 4. So today we're in session 2, which is physics, what is time and space. So we are going to read just a little bit of the scripture. And I'm going to read just these 4 verses for you. John 20, verse 19. Then the same day at evening, being the first day of the week, when the doors were shut, where the disciples were assembled for fear of the Jews, came Jesus and stood in the midst, and saith unto them, peace be unto you. I'm going to say something next, and this is not to be blasphemous, but this is simply to look at it as a skeptic would look at. Never mind that someone is claiming to have risen from the dead, but there's another claim here that is completely defies physics. And what it is, it says the doors were shut and he just pops up in the middle of the room. How is that possible? If I close all the doors and windows here, there's a roof, there's a ceiling, there's 4 walls, somebody just pops up in the middle of the room. How is that possible? It defies physics. It doesn't make any sense. If you were a scientist reading this about 150 years ago, you'll say, look, this is just not possible. This is just fiction. Let's read on. Jeremiah 23:24. Can any hide himself in secret places that I shall not see, him, saith the Lord? Do not I fill heaven and earth, saith the Lord. This too doesn't make any sense at all. Here I am standing here. I occupy this space, right? I don't occupy that space. I can walk over here. It takes me a finite amount of time to walk over here. Now I occupy this space. I don't occupy that space. Here, God is making a claim that he occupies all the spaces all the time. That doesn't make any sense either. So let's look at these verses as a scientist would look at, right? The first problem, the doors were shut and he pops up in the middle of the room, is a space problem. How do you pass through solid objects? How do you pass through space when there are barriers in front of you? So that's a space problem. The second one, I feel heaven and earth, is a space and time problem. Like I showed you, I can occupy this space at this moment. I can occupy this space at this moment. I can occupy both spaces. I can't do it at the same time. So the second verse is a time and a space problem. Isaiah 34:4. All the host of heaven shall be dissolved, and the heavens shall be rolled up like a scroll, and their host shall fall down as the leaf falls from the vine, and as fruit falling from the fig tree. Revelation 6:14. Then the sky receded as a scroll when it is rolled up, and every mountain and island was moved out of its place. Excuse me. So these last two verses are a surprise for the end. Somehow the first two verses rolls into the last two verses, and I'll talk about that in the end. It talks about the heavens being rolled up like a scroll. We'll talk about that. So that's our Bible reading for today. Let's get into our material. Oops. Okay, so I defined the problem for you in the beginning. There's two problems, time and space. So we're going to try and understand science and say, what is time and what is space? What is this? We never think about it. What is time? What is space? Let's explore that question. So what is time? It's something that prevents everything from happening all at once. Okay, that's one way of thinking about time. Stuff happens and then other stuff happens afterwards. That's kind of time. If you study the entropy model of physics, entropy is tied to time, and there's a whole thing there. You don't have to worry about it. Let's worry about how is time measured. So typically we are governed by the movement of the sun. So we measure time as day and night. And that's how it's been done since ancient of days. So we use the movement of the sun. And then people said, well, that's too big a unit, right? There's a lot of things I can do during that time. So I need to divide it up some more. So they said, okay, we will divide it into parts. We'll call it hours and we'll call it minutes. And then even the minutes, when we started getting into science, even a minute becomes too long. So we said, let's divide the minutes some more. And they said, let's call them seconds. And then you can go further. There's microseconds, nanoseconds, femtoseconds, and so on and so forth. So this is what we used to, this is not what time is, but it's more like how do we measure time? This is what we measure time with. These are the units we use. What is space? When I ask somebody what is space, they tend to say, well, outside the earth, right? That's space. That's where the planets are. That's where the stars are. That's space. That's not what space is according to science. That's a colloquial use of the term space. What space really means for science is the fact that there are three dimensions: length, breadth, and height. Those are the three dimensions. If I take my arm, I can move it back and forth. That's depth. I can move it side to side, up and down. That's breadth and height. This fact that I can move in something is what science defines as space. The fact that there's something to move into is what space is, according to what science defines it as. So we understand space, but we don't quite understand what time is. We know how to measure time, but we don't quite understand what it is. So once you understood time, we start to think about what is a minute. What do you call a minute? So it wasn't defined until the 16th century when the pendulum clock was invented. When the pendulum clock was invented, they said, oh, I can divide this minute into smaller units. Okay, I'll say 60 minutes, 60 oscillations of the pendulum is 60 is 1 minute, and therefore each of those oscillations is 1 second. And what is a second? So first of all, back when we didn't have a lot of science, 1 second of time was defined as 86,400 of an equatorial day. So why equatorial day? Because on the equator, we have exactly 12 hours a day and 12 hours a night. So you take that entire 24-hour period divided by 86,400, that's a second. That was the first definition. Then science decided that wasn't accurate enough. So then they discovered this thing called a cesium atom. It's called cesium-133. And they said that if you have that many, I can't even read that number. If you have that many oscillations of the cesium atom, that is 1 second. What it is you take this cesium is a kind of metal, you take it and you excite it with energy, the electrons that are around the atom will jump and it will jump back. And if you continue applying energy, it'll jump back, it'll jump back. Turns out no matter how much energy you apply to it, the speed at which this electron jumps is always the same, and it's extremely accurate. So you can precisely define what a second is using a cesium atom. Then that the cesium clock is accurate. If you build a clock using cesium, it's accurate to 1 second every 1.4 million years. In other words, if you leave this clock calibrated and you leave it running for 1.4 million years, it'll only lose 1 second. Turns out that's not accurate enough. So somebody went and said, I can do better. I can do a strontium clock. Strontium clock works on the same principle. Strontium is also a metal. It works on the same principle, and it is accurate to 1 second in 15 billion years. So if you build a strontium clock and you leave it running for 15 billion years, it'll only be wrong by 1 second. We often think our digital watches here are very accurate. They're not. They will lose several seconds every single day. But you don't notice it because it doesn't matter. Now, this particular watch happens to be connected to the internet, so it actually connects to a cesium clock, an atomic clock somewhere in the country, and it keeps correcting itself. It's not that this watch is accurate, but it is connected to a very accurate clock. So I don't see the errors that this watch can introduce. And the reason this is important, why am I going on and on about clocks and 1 second and 1.5 billion years? I mean, who cares? I'm not going to be around. The reason this is important is because when you can measure time accurately, you start noticing certain things that's wrong with the universe, right? That's why this is important. You start nudging at the fabric of the universe and you start noticing certain things. And let me show you what are a couple of things that you start noticing. You come up with this guy. He had a great sense of humor. I don't think his hair looked like this all the time. He just liked to be funny, and that's why he looked like this. This is Albert Einstein. He came up with this theory called general relativity. General relativity is a very big thing, but we'll only pick on a couple of topics that came out from general relativity. What we read is that time is dependent on speed. What that means is that if you had a strontium clock and you were standing still, and I had a strontium clock, and we coordinated our strontium clocks. Now remember, these clocks don't vary from each other more than one every couple of billion years. So we synchronized our strontium clocks. And then let's say I got on an airplane with my strontium clock, and I flew around the Earth, and I came back. And now I take my clock off, and I put it next to yours, and we compare times. What you find is that less time has passed for me than it has for you. The reason isn't because the clock is inaccurate. The reason is because time changes with speed. I still see when I'm on that airplane that 1 second or 1 minute or 1 hour still looks like 1 second, 1 minute or 1 hour to me. But when I take my 1 minute and then I compare it to your minute, because you're standing still, your minute is a little longer than my minute is. Time actually flows differently with speed. That's the first thing that general relativity came up with. And this has been proven by experiments. The second thing that it tells us that time depends on gravity. The higher the gravity, the slower the time. And this is the topic that we're going to really hammer on today, that depending on time changes, depending on what gravity field you are in. And the reason I went on and on about these clocks is because you need these accurate clocks to see the difference. See, I'm standing at a higher spot than you. That means technically I'm experiencing a slightly lower gravity than you are down there. So if I had a Stoneham clock and you had a Stoneham clock and we looked at each other's clocks, it will vary slightly. Mine will be slightly faster or slightly slower. And you need a Stoneham clock to know that. And that's why I was going on and on about Stoneham clocks and all of those things. Time depends on gravity. So the question is time same for everybody? It's not. And here's what I want to show you. There's a atomic clock in Boulder, Colorado, which is up on a mountain. And there's an atomic clock in Greenwich, England, which is at sea level. These are perfectly synchronized when they started it. It turns out the clock in Colorado is ticking faster than the clock in Greenwich. Now, for the purposes of this illustration, it's showing like a 5-minute difference. It's not a 5-minute difference. It's maybe a couple of nanoseconds different. But the Stoneham clock is so accurate, you can actually see gravity is changing time. And you can see that when you have this elevation difference between the two, that the atomic clock in Boulder, Colorado is ticking faster than the atomic clock in Greenwich, England. So now you ask yourself, why? Why would time change with gravity? To understand that, this is a good picture to keep in your mind. Okay, so what this is showing is there's planet Earth. It's in space. And you know that any object like a meteorite or a comet that's flying through the Earth will get pulled in by the Earth and it falls into the Earth, right? It'll hit the Earth eventually. When we envision this thing, we call it gravity, yes, but we think of gravity as being like a magnet, right? You take a magnet and you take an iron nail, you put the two together, the iron nail flies to the magnet. And we think that gravity is like that. It's really not. That's not how you should think about gravity. Gravity, you need to think about as if it were a sheet. See, all reality, space, the 3 dimensions that we're thinking about, you need to imagine it as being like a rubber sheet that's been stretched over the universe. Okay, that is what space is. This is what science is showing. I'm not making this stuff up. There's a lot of science that goes behind proving stuff like this. I'm just giving you the cliff notes here. All of reality is like a rubber sheet stretched out across the universe. When you put something heavy on that rubber sheet, like the Earth, it bends that sheet. So imagine this rubber sheet is a universe, it's space, time, 3 dimensions. I put a heavy object like the Earth on it, it bends space. What happens when you bend space is that the time far away from the Earth is different from the time closer to the Earth. This is science, this is proven. When space bends, time bends. If I was standing close to that clock that's near Earth, I would see 1 second, just like 1 second. If I was standing further away at that clock, I would still see 1 second as it was 1 second. But if I were standing here and I looked at both clocks together, what I find is that the more the gravity, the different the time is. This clock and that clock doesn't match because we are bending space. And when we bend space, time also bends. So the term you will hear often from physicists isn't space and time. They call it space-time. Space-time is one thing. They're intricately designed. Last week, I talked about before time began. I'm not going to repeat it, but I want you to go back to it. Before the Big Bang, there was no space. Before there was space, there was no time. Therefore, when the Bible says before the time began, it is giving you a scientific statement that there was a time when there was no time. Before the Big Bang, there was no time. I talked about it extensively last week. I won't repeat it, but keep that in mind. So this is what it is. It's space-time. When you put gravity in it, it bends space-time. So if you see like a rock or a meteor coming across this rubber sheet, you can see how it falls down into the sheet and into the Earth. So that's how you need to think about gravity. It's not a magnet attracting a nail. It's more a heavy object that's bending a rubber sheet, and everything's traveling on that rubber sheet will fall down into that hole. That's what it is. And if it's fast enough, it'll start orbiting that hole because it's like a whirlpool, creates a whirlpool, it starts orbiting. This is how satellites orbit. And if it's really, really fast, it can just skim this hole and fly off. And this is how a lot of meteors come by and just skim the earth and go off because they're going so fast that they can actually escape this hole. This is how gravity works. This is space-time. I'm going to ask you a couple of questions. How do you fold things? What is folding? I just told you that space-time folds, right? It bends, it folds. How do you fold things? Here's a piece of paper right here. It's show and tell time. Piece of paper here. How do I fold it? I fold it like this, right? I've got another illustration here. This is a really cool toy. Imagine this is a piece of paper. I know it's thick, but ignore that for now. Imagine this is a piece of paper. How many dimensions does it have? 1 and 2. It's got length and breadth. 2 dimensions, right? An easier way to envision that is this piece of paper, right? It has no thickness. So what does it have? It has a length, it has a breadth. This is a 2-dimensional object, right? It's a 2-dimensional object. Imagine this is a 2-dimensional object. It isn't. I'm saying just ignore this 2-dimensional object. I ask you to fold it. How do you fold it? What's this? I just folded it. What did I do? Pay attention very closely. What did I do? 2-dimensional object. This dimension and this dimension is all that exists. Here's how I fold it. Yeah, this is tricky. Like this. To fold a 2-dimensional object, I must have a 3rd dimension. Do you see what I'm saying? If it's a 2-dimensional universe where only length and breadth exists, I cannot fold this object. In order to fold it, I must have a 3rd dimension going this way. So when I fold a 2-dimensional object, I must have a 3rd dimension. Now I folded it into a 3-dimensional object. This is 3 dimensions. It has length, breadth, and height. I hand you this object and tell you to fold it. Can you do it? You can't do it. You cannot fold this object anymore because this is a 3-dimensional object. I don't have a 4th dimension into which I can fold it. The lesson to learn here is that to bend or fold a n-dimensional object, you need at least n plus 1 dimensions. If you imagine a string, it's single dimensional. I can bend it on this direction and I can bend it in this direction because it's a 1-dimensional object. It lives in a 3-dimensional universe. I can bend it 2 ways. If I have a flat sheet, it's a 2-dimensional object. I live in a 3-dimensional object. I can bend it 1 way into the 3rd dimension. So to bend any object, you need another dimension. Once I'm at 3 dimensions, I can't bend this anymore without breaking it anyway. I can't bend it. There's nowhere to bend it to. And yet, what I showed you just now, what Einstein's general relativity is showing, is that space bends into something. What is it bending into? Rather than go through all the science and all the experiments and all of the math that are doing, most of which I don't understand anyway, just accept this. We live in a 3-dimensional universe with length, breadth, and height and time, but there is an additional dimension that we cannot get to. There is at least 1 more dimension. How do I know it? Because the science shows that space bends. Science shows that time bends. I just demonstrated to you, in order for something to bend, there must be an additional dimension. So we know there is at least 1 more dimension out there that we can never get to. Now, in our mind, we're thinking, well, what is this 4th dimension? I see my space around me. What is this 4th dimension? And you're having trouble envisioning it. Well, yes, because your brain is only equipped to deal with the 3 dimensions. When the math starts showing a 4th dimension, frankly, everyone was startled. But the math is showing it. There is another dimension that everything can fold into. So we know there's at least 4 dimensions in the universe. This is without question. Science just accepts it. And the moving of time is what showed us this. And I want to take you back through the reasoning that we have done so far. We said that gravity changes time. Well, why? Gravity changes time because gravity bends and folds space. Well, if gravity is bending and folding space, then that means there must be an additional dimension somewhere. And this is why I went through all of that with the time and the clocks and why we're measuring it, just to show you that all of reality can be bent. That means there must be an additional dimension somewhere. Well, why is this important? I'm going to try and bring together Isaiah, Apostle John, and Albert Einstein. Isaiah 34:4, all the host of the heaven shall be dissolved, and the heavens shall be rolled up like a scroll. What's that saying? Well, what it's saying is the end of all things and the end of the universe. But based on what I just told you, read that verse again. All the heavens shall be rolled up like a scroll. We know there is an additional dimension. Science shows it. 200 years ago, if you read this as a scientist, you'll say, that's ridiculous. What do you mean? The heavens shall be rolled up like a scroll. That's just poetry. Fine, it's poetry. We'll ignore it. I just showed you that there's something that all of space rolls into, can be folded into. Now look at that verse again. The heavens shall be rolled up like a scroll. What Isaiah is telling you is that the whole universe will be rolled into that other dimension, just like physics tells you it is. This is the idea that I'm trying to convey to you. The idea isn't to tell you that the Bible is a book of science and there's a lot of science in it. No, that's not what it is. The idea that I want to hammer into everybody's head is that the more science you understand, the more easily the Bible reads. There's so much science in the Bible that you can only understand when you study science itself. There's so many people out there trying to tell you that if you're a scientist, you can't be a believer. I beg to differ. I just taught you a basic understanding of multidimensional physics, and suddenly Isaiah 34:4 takes on a whole new meaning. And this is the idea that I'm trying to hammer home today. Revelation 6:14, the sky receded as a scroll when it was rolled up. There it is again. All the universe rolled up into the other dimension. I just showed you how the other dimension exists. Now, the question that we always ask, as we did last week, is, could this be a work of fiction by an ancient scribe? Remember, we're looking at the Bible with a skeptic's eye, right? Could this be a work of fiction by an ancient scribe? Maybe, but boy, he has some imagination. That he's saying the whole universe is rolled up like a scroll. I could imagine him saying that, well, the universe kind of disappears and all that, but he's very specific in his word. He's saying that everything is rolled up in another dimension. It seems to be either he has a great imagination, John and Isaiah 4,000 years ago, either has great imagination, or the person who built it in the first place wrote it. To me, I tend to agree with the latter explanation. The next question we ask ourselves, does this hold up to scientific scrutiny? You never thought about taking Isaiah 34 and applying physics to it, did you? Well, because most of us don't need to. The next time a skeptic comes and tells you that Bible is unscientific, point him to this. Does it hold up to scientific scrutiny? Yes, it does, because the heavens can be rolled up into this additional dimension. And this is what physics is showing us. So, multi-dimensions are a little bit hard to understand. So I'm going to introduce you to Mr. and Mrs. Flat. And I have show and tell again. Here's a piece of paper. And here's two individuals there. Here's Mr. Flat and here's Mrs. Flat. We can't understand a four-dimensional universe, where we can definitely understand a two-dimensional universe because this paper is it. So imagine this doesn't exist, right? This is the third dimension. Imagine this doesn't exist. For Mr. and Mrs. Flat, only two dimensions exist. This length and this depth. This is all that exists for them. They have no capability of leaving the paper to the back or to the front. Is it possible for Mrs. Flat to be here and here at the same time? Any way she can do that? Well, no. Because in order for her to be with him, she has to move across this dimension, this way, or this way, to be with him. She has to move. There's no way for her to be there and here at the same time, right? Makes sense. Two-dimensional universe. Second, is there any way for her, here's Mr. Flat, he's in a room, this is a doorknob. Is there any way for Mrs. Flat to enter Mr. Flat's presence without going through that door? Well, no. It's a two-dimensional universe, remember. So when she moves to here, this becomes a barrier. She can't get through. She has to open that door so she can get in and be with Mr. Flat, right? Now here I come along, I'm a three-dimensional being. I can take my hand, I can move it this way, I can move it this way. Well, here's the magic. I can move my hand this way, and I can move my hand this way. I can move along that additional dimension, which these two can't do, okay? Now watch this. Look what I do. Can I be with both of these individuals at the same time? Watch this. What did I just do? I'm with both of them. I am touching both of them at the same time. I'm not traveling the distance between them. I don't need to because I have a third dimension that I can approach them by. Do you see what I'm saying? Do you see the point I'm trying to make? Having access to an additional dimension gives me capabilities that are completely out of the understanding of these two people here. And by the way, when I touch them like this, they don't see my finger. All they see is a circle or an oval because they can't see all of who I am. It's kind of like God, right? We don't see all of who he is. We only see that part of him that he's projected into our universe. So when I do this, I am with both of them. They can see there's a circle in their present, and the other guy says, hey, that circle is here too. But they think I'm a circle. And I'm with both of them at the same time because I have access to a third dimension. Here's the other thing I can do. The room is locked. No one can get in. Watch this. What did I just do? I just entered the room. I didn't open the door. I didn't open the window. I just entered the room. Why? Because I have access to the fourth dimension, to the third dimension that these two don't have access to. So let's look at those verses again. Then the same day at evening, being the first day of the week, when the doors were shut, where the disciples were assembled for fear of the Jews, came Jesus and stood in the midst and said unto them, peace be unto you. When you read this, and now that you understand multidimensional physics, does this make just a little bit more sense, or does it make a little bit less sense? Now, I want to caution you here. I don't want to stand here and try to say that I am going to explain the science of God. No, God is God, okay? He just speaks and it is. I'm not trying to explain the science of how God does things. What I'm trying to show you is that science is showing these things are in fact possible. We don't have the technology to access that dimension, but we know it exists. That's the idea that I want to show you here. 200 years ago, you read this and it just makes no sense. How does one enter a room like that? You read it now and you understand there's an additional dimension. It makes a whole lot of more sense, like I just showed you with Mr. and Mrs. Flat. Here's another thing. Can any hide himself in the secret places that I shall not see him, saith the Lord? Do I not fill heaven and earth? I just showed you how I can be in two places at the same time in their universe. I can be at both places. I can see both of them. They're both in a two-dimensional plane. Looking from a third dimension, I can see both of them. Again, 200 years ago, this made no sense. You read it now, you understand multidimensional physics. You read this and say, it's so obvious. If I had access to that fourth dimension, I can probably see all of you at once. See, this two-dimensional representation is a way to help a three-dimensional being understand it. You have to go down one dimension to understand it. And you understand those things and you read these verses, it takes on a whole new meaning. The more you understand about science, the more sense the Bible makes. Could this be a work of fiction by an ancient scribe? You know, if I was making up a story about how Jesus resurrected and everything, I'm not going to write ludicrous things like he appeared in the middle of the room. I'm not going to do it. I'm going to make it as convincing as possible. I'm definitely not going to say that the first people who saw them rise from a grave were women, because women's witnesses is not acceptable in a court of law. I'm not going to write stuff like that, but this is even more difficult to believe, that somebody has appeared in the middle of the room. Could this have been a work of fiction? I don't think so, because you're trying to convince somebody, you're trying to fool somebody. This is not how you do it. But if you understand science, it says, yeah, he could do it. He could do it. Does this hold up to scientific scrutiny? I just demonstrated to you that, yeah, it does. When we understand that the universe isn't three-dimensional, you have no problem reading this and understanding, yeah, it can be done. And this is the whole point. The more science you understand, the easier the Bible reads. I challenge you to find another holy book written this way. I challenge you. There isn't one. You know why? Because the one who built all of this wrote the book. The others are works of fiction by an ancient scribe. That's the difference. You will not find another book like this. You will not find another book that says light was created. It is a completely ridiculous idea to say that light was created. And yet we know at the Big Bang, light was created. Before the Big Bang, there was no light. There is no book that calls out science like the Bible does. We have 10 minutes, I think, according to time. Well, that watch is slow. Okay, I'm just going to quickly. We have some bonus material, maybe a few minutes. If nobody minds, I'll just go through it. We'll just talk about quantum mechanics. I'll be very quick, I promise. What is quantum mechanics? Now, as soon as you hear the word quantum mechanics, everybody's eyes glaze over. Oh no, a bunch of propeller heads, I don't care. But it's not really that complicated, okay? Quantum mechanics isn't that complicated. All quantum means is that it's a discrete unit. That's all it means. It's the science of subatomic things. And when you start studying atoms and molecules, it turns out they're discrete units. In other words, if you take a piece of string and you cut it in half, you have half the length, you cut it in half, you have half the length, and you keep cutting, you think you can keep doing that infinitely, right? Well, you cannot. You will reach a point where it cannot be divided anymore. Think of it like your phone screen. You're looking at your screen and it looks like a picture. You bring it close to your eye, you can see dots on the screen. Turns out all the universe, everything that you can touch and feel is made out of tiny little dots. And you can't go below the dots because there's nothing there. They're all made of dots. So that dot is called a quantum. That's all it is. It just means a piece that cannot be further subdivided. For example, a photon, you must have heard the word photon. A photon is a quanta of light. It's the smallest unit of light. It's a particle and it's a wave. It goes across the space and it's called a photon. You cannot divide it any more from that, and it wouldn't be light if you did, but you cannot. And it's basically used for subatomic particles. That's all it is. And quantum mechanics is simply the study of something that is at the quantum scale. That's all it is. There's this thing called spooky action at a distance. And what it is that if you take one photon of light and you split it into two, which you can actually create two photons. They're still two photons. They're not a half photon. But you can take one photon and I can split it into two. And let's say I kept one photon here, and I took the other photon and I put it on the other side of the universe. And they're not connected in any way. Like one photon's here, one's on the other side of the universe. You know, a weird thing happens. As soon as I touch this photon here, the photon on the other side of the universe knows that it's been touched. This is called spooky action at a distance. The math showed up in Einstein's equations, and he didn't believe it. He could not believe that such a thing could be possible. And he's the one who coined this term spooky action at a distance, because he just couldn't believe it. But it's true. I just showed you how a fourth dimension can give you capabilities. That's only one way that action at a distance is possible. Here's another way. When you split a photon, distance just stops happening. Distance has no meaning. You can instantly communicate with that person at the other end of the universe. So that's spooky action at a distance. It comes out of quantum mechanics. Here's the other thing. Here's what atoms are made out of, right? It has a nucleus. The nucleus consists of neutrons and protons, and it has electrons that are orbiting around it. And it looks like a nice little packet when you look at it in this picture. But you have to ask yourself, how big are the atoms and how far away are the electrons from the nucleus? Okay, so in order to understand that, let's imagine that the nucleus, the blue and red thing, is about the size of a tennis ball. This is approximately the size of a tennis ball. If this is that nucleus right here, you know where the closest electron is? The closest electron is a football field away. What's between these two? Nothing. There's nothing there. There's energy, there's electrical fields, there's nothing there. I tap on this podium, it seems pretty solid, right? It takes quite a few of us to lift this thing up and move it to the side. And yet there's more empty space in this podium than there is stuff. Because there's so much empty space within the atoms that the distance between the nucleus and the electron is so far away that there's more empty space in the solid podium than there is. It turns out that this reality that we're all obsessed with, that we are all trying to get the best life out of, it really isn't there. Most of it is empty space, and that's what we're fighting over. There's nothing in there. And that's what the atoms are made out of. Atoms have another very interesting property. There's energy in there. There's energy in there. You can take energy out of the atom. You know what I mean? This thing, I'll just skip this. It's not important. Here's how you get energy out of an atom. You take uranium-236, you take one of those neutrons from another atom, and you bombard the uranium-235, and the uranium-235 for a very brief millisecond becomes uranium-236 because the neutron that you sent has embedded itself into the uranium, okay? But that's unstable. It can't sit there in that state. There's one extra neutron, it doesn't like it. So what happens is that uranium-236 splits into krypton and barium. And 3 neutrons that are left over, because they don't belong in krypton and they don't belong in barium, 3 neutrons that are left over gets thrown out. And what happens in the middle of that is that a tiny, tiny fraction of the atom gets converted into energy. You think that it's a lot, it's not. It's a very tiny, tiny fraction of the atom that is converted into energy. And these 3 neutrons that get thrown out, they go and hit 3 new uranium atoms. And those 3 uranium atoms give off another 3 neutrons. This is what's called a chain reaction. Once you get it going, a chain reaction happens, and you can release a tremendous amount of energy by just splitting the atom. What you're doing, that electron and proton, you're just taking out a little bit of energy, just a tiny bit of energy from it. That's what you're doing. And what happens when this energy is uncontrolled? This is how a nuclear weapon is built. I've seen videos of nuclear weapons going up, and it's just watching it on video is a truly frightening thing. The Russians have built, and the Americans too, I'm sure, have built a nuclear weapon where the explosion is so strong that the top of the mushroom cloud leaves the gravity well of the Earth. It simply goes off into space. That's how powerful it is. And you look at that power, and you look at this equation, and you realize only a very tiny fraction, a tiny minuscule fraction of the mass of the atom is being converted into energy. And the whole bomb is maybe about this big. That's it. Releasing a very tiny fraction of that can make a nuclear weapon. What happens if I could release all of the energy in one atom? One atom, if I could release all of it. Let's take a look. 2 Peter 3:10. But the day of the Lord will come as a thief in the night, in which the heavens will pass away with a great noise, and the elements will melt with fervent heat. Both the earth and the works that are in it will be burnt up. I want you to stop for a minute and examine the scientific accuracy of this verse. What is Paul saying? What is Peter saying? Very specific scientific terms. The elements. He's talking about atoms, the elements, not compounds, not liquids. The elements will be what? Will be burnt up. I showed you the atom. I showed you what happens when you release a tiny amount of energy. Here's an additional fact. Nobody really knows what's keeping the atoms together. They've got energy and they're all just bound up in this little packet. Nobody knows what's really keeping it together. What happens? I personally believe that the Lord is keeping it together, because in me, all things are kept together, and I contain all things. What happens when he lets go? What happens when the Lord lets go and the elements fly apart? it will literally burn. I showed you a nuclear explosion. That's just a tiny fraction of the energy in an atom. What happens when all of the energy in the atoms are let go? The elements will be burnt up. 2 Peter 3:20, again, I'm looking again of the hastening of the coming of the day of the Lord, because of which heaven and earth will be dissolved, being in fire, and the elements will melt with fervent heat. You know what? This makes a lot of sense scientifically. All you have to do, these atoms, protons, neutrons are held together. All he has to do is let go. And the elements will burn with the fervent heat. Could this have been a work of fiction of an ancient scribe? Maybe. Maybe. More important question, does it stand up to scientific scrutiny? Well, yes, it does. For an element, all you have to do to make it burn is to let go of the atomic bonds. When you let go of the atomic bonds, all the energy is released as fire, and the elements are consumed. See, this is another verse where you can read it and you can understand the spiritual significance of it. And yet when you understand a little bit of science, it takes on a whole new meaning, because it's literally describing scientifically what is going to happen when an element is taken apart. It burns. And that's what these verses are talking about. That seems like a pessimistic way to end, but it shouldn't be. It really shouldn't be, because our place in eternity is completely different. John 14:1, let not your heart be troubled. You believe in God, believe also in me. In my Father's house are many mansions. If it were not so, I would have told you. I go to prepare a place for you. And if I go and prepare a place for you, I will come again and receive you to myself, that where I am, there you may be also. The whole point in telling you how the Bible can talk about science is to show you that what is written in the Bible can be relied on. It can be relied on because someone who had supernatural knowledge wrote it. If you can believe those passages, and if I can prove those passages to you from science, then you can believe this. Then you can believe this, because it says that the elements will burn with a fervent heat. Don't worry about it. You're mine. You're mine. That is the thing that we need to understand. After we are convinced ourselves that there is something in this book that's special, you need to start looking at the other places in the book. And the other places in the book tells you that there is a God who loved you so much that he sent his son to die for you on that cross. And when the elements burn, we don't have to worry about it, because he has prepared a place for us. And that's where our eternity is. Time, space will end. Science is telling us it will end. It's heading to a heat death. We know it. But our place is going to be with him for eternity, where time and space won't matter anymore. Eternity is what it is. Once you have removed matter from the equation, there is no time. That's what science is telling you. Suddenly, the Bible makes a whole lot more sense. Let's pray. Our most loving Heavenly Father, thank you for this time you have given us when we could look at some of the wonders of your creation. Thank you so much because of all the people who have been here, who have been able to listen. And we pray for those who have not been able to be here today. Wherever they are, guard them, guide them, keep them safe. As we go about our week, be with us. Help us to be witnesses for you. Help us more to understand who you are, and that you are very real, and that you love us so much. And it is because of you that we have life and breath, and all that we are and all that we see and that all that we ever will be is because of you. Send us away with this thought today. We ask in the name of our Lord and our Savior, Jesus Christ.